For this video, we're going to talk about writing ratios and proportions. There is a PDF that you can print out if you'd like to follow along with that. First thing is, what is a ratio? It's a comparison of two quantities through division. We can write it like this as A to B or A colon B, or this is the division format, like a fraction A over B. But each one is read as the ratio of A to B. Ratios should be written in simplest forms, just like fractions are written in simplest form. Here's an example. Volleyball team plays 14 home matches and 10 away. 14 home, 10 away. They want us to find the ratio of home, so home came first, to away games. So the ratio of home can be written as H over A, and home is 14, and away games are 10. And of course, the ratio is 10 to 14, home to away, but we should simplify it. That is the ratio, but we should simplify it just like a regular fraction. So we're going to divide by 2, divide by 2, and we end up with 7 to 5. We could say 14 to 10, but the simplified ratio is 7 to 5. 7 home matches to 5 away. On B, we're going to ask home matches to all matches. So it'll be home matches over all matches. And all matches is the combination of the two. So that's going to be home matches, again, still 14. All matches, well, that's going to come from the home plus the away matches, and we go ahead and add that up, and we get 14 over 24. And we can still simplify this. So even though the ratio of home to all is 14 to 24, I can still divide by 2 and reduce that to 7/12. So 7 home to 12 all the way. 7 to 12 is the ratio of home to all matches. Proportion. Proportion is simply an equation that states that two ratios are equivalent. In other words, two ratios with an equal sign between them. This is just a general equation. The ratio of A to B is equal to the ratio of A to D. And as long as B and D, which are the denominators, do not equal 0, that is okay. Can't divide by 0, so let's say we have 3 over 4 is equal to 9 over, let's say, 12. So the ratio of 3 to 4 is the same ratio as 9 to 12. Or I could say 6 to 8. You could even go a step further, 6 to 8. This creates a proportion because those are equivalent. That creates a proportion because those are equivalent. Or I can get rid of that and look at these two ratios and call them a proportion because they are equivalent also. Solve a proportion. Well, this is x over 30, so that's a divide. So to undo that, we're going to times by 30. Times by 30. Now remember, this is 30 over 1. So 30 times 11 is 330 over 6. These 30s will cancel each other out, leaving x. Now go ahead and simplify that, and I believe that's going to be 55. So 330 divided by 6, just double check that. 330 divided by 6 is 55. So the value of x that makes this ratio equal to that ratio would be 55, and that's how we solve the unknown part of a proportion, at least until we show you how to do multi-steps. Here's another one. This is a divide by 35, so we're going to undo that by timesing by 35 on both sides. Don't forget that's over 1. So W is going to equal, use your calculator here, I think that's 140, but I'm going to just double check it, calculator. It's 140 over 7, and then of course simplify it, so W ends up equaling 20. So 20 over 35 is equal to 4 over 7. Here's another one. Got to divide by 12, so I'm going to times by 12. 12 over 1 times by 12 over 1. 12s will cancel out. And when I say cancel out here, what I really mean is they become 1, and 1 times m, that should be an m, 1 times m is equal to m because that's the multiplication identity property. 9 times 12 is going to give you 108. 1 times 2 is just 2. And then, of course, simplify that so that m ends up equaling 54. So that the value of m here would be 54 over 12 is equal to 9 over 2. Let me point something out to you. This right here, I'm just going to write 54. You'll notice here that since the 9 over 2, 9 was bigger than 2, that this ratio over here would have to have a bigger number on top in order to be equivalent. That's a proportion statement that's always going to be true. If you look back here, 4 was smaller than 35, but the answer I got for W was also smaller. I'm sorry, 4 was smaller than 7, and the answer of 20 was smaller than 35 as well. And looking back here, 11 was bigger than 6, therefore we would expect X to be bigger than 30, and it was bigger. It was proportionately bigger. Setting up a proportion. So here's our scenario, and then the book shows us a little technique here. I've got another one I can show you too for setting this up. It says a recipe for tomato salsa calls for 30 tomatoes to make 12 pints of salsa. How many tomatoes are needed to make 4 pints? So this is the given information, 30 tomatoes to make 12 pints. We've got 2 recipes. We've got a small recipe. We've got we got the smaller one. We've got the 12 normal recipe. So this is actually the 12 here. We've got tomatoes and pints. The original recipe would be how many tomatoes, which is going to be 30, to how many pints. And then the smaller recipe, and the reason we know it's smaller is because we started with 12 originally, and we're going to make 4 instead. But pints goes over here on the smaller recipe. That was 4. And we're talking about tomatoes. How many tomatoes do we need? So you can use anything you want for a variable. I'm going to go ahead and use t instead. So the ratio of t to 30 is going to equal the ratio of 4 to 12. And it's at that point you can use the previous technique that we used here to go ahead and solve for how many tomatoes you need. The next page shows a similar one. The difference is they have the recipe this way and the tomatoes and the pints on the side instead. So let's go to the normal recipe. The tomatoes was 30 still, yep, 30, and the pints were 12. We're going to only make, on the smaller recipe, 4, and we're still going to use t for tomatoes. So I have t over 4 is equal to 30 over 12. And this is going to be the same proportion as the last one. You'll notice on a diagonal here I have a 12 and a t and a 30 with a 4. And on the previous one I have a 12 and a t and a 30 and a 4 on the same diagonal as I did before. There are multiple ways you can set this up. I like to look at this as simply calling it tomatoes over pints. So tomatoes over pints should equal tomatoes over pints. You can do that. You can do pints over tomatoes equals pints over tomatoes. So small recipe, big recipe, or normal recipe, or vice versa. If we wanted to, we could do tomatoes over tomatoes and pints over pints. Okay, as long as the recipes match up, that would all work. There's a bunch of ways you can solve these things. Okay, here's a word problem. Elevator takes passengers from the lobby of the John Hancock Center in Chicago, travels 150 feet in 5 seconds. So it travels 150 feet in 5 seconds. The observation level is located at the 94th floor, which is at 1,029 feet. That's above ground level. Find the time. Find the time the elevator has to travel from the lobby to the observation level. Now, since they're asking me for time, I'm going to put my time value in the numerator. So time over feet. And that's how I'm going to set up my ratios in my proportion. So I'm going to put time over feet equals time over feet. Okay, so I create my setup for my proportion. Well, the first ratio they gave me with time in feet was 5 seconds and 150 feet. So 5 seconds and 150 feet. And the second one they gave me was the number of feet, which is down at the bottom. This is feet. I decided to start with time on the top, feet on the bottom. So 1,029 on the bottom. And I need to find the time value it takes to actually get up to 1,029. And And the way we solve this is, let me go ahead and erase this. This is divided by 1,029, so I'm going to times by 1,029 on both sides. 1,029. So this will cancel out, leave me with time equal to, this is over 1, 1,029 times 5 gives you 5,145 over 150. Oops, 150. And then I'm just going to divide those out to get my actual time value. So go ahead and take 5145 and divide it by 150. And the time value comes out to 34.3. I think it was in seconds. Yes, it was in seconds. So it takes 34.3 seconds to get to the top of the observation level from the lobby at a rate of 150 feet per 5 seconds.